Hi friend, in this tutorial we are going to study RL78 ADC converter and its programming in Coveter IDE. The ADC converter is used to convert analog input signals into digital signals. The RL78 ADC supports the SAR ADC. It supports 10-bit or 8-bit resolution. It's having an internal reference. It supports the frequency 32 MHz. It also supports the software triggering, hardware triggering, and also having continuous scan mode and select mode. So open your Coveter IDE and create a new project quickly. Select the MCU part number. I am selecting the R5F100LE 64 pin, which is having a ROM 64 kilobyte and RAM 4 kilobyte. Then kind of the project, select the application, then give the project name ADC tutorial. Okay, give the 1 ADC tutorial 1, and this is a place of the storing the project and create. Once you create the project, you see ADC tutorial 1, selected part number is R5F100LE. This is a top view of the MCU. Now I have not selected any pin, so all these pins are showing the empty one. We show the how to use that one also. So next option is a code generator. So I want to use the code generator. The code generator is used to generate the driver. So here first we need to configure the clock. So fix this setting. In clock setting, next there are some multiple operations: low voltage main mode to high main mode. Select the operation standard for the 2.7 volt to 5.5 volt. Then main speed, this is a Hoku high speed on chip oscillator I have selected, and other settings as it is. This CPU and peripheral clock setting, this is 32 megahertz selected. This is block diagram, and other option is on chip debug setting. In on chip debug segment, if you have your own hardware, so you need to use this setting, use this. Then emulator, select the which you are using, the emulator E1, E2 or E2 Lite. So mostly nowadays many users are using the E2 Lite. So this E2 Lite I have selected. So I also have the E2 Lite I am using. I selected the E2 Lite. Keep the all settings as it is. Then I don't want to use now the watchdog timer, so it is used. So make it as an unused. So see, here is a port, interrupt, ADC and ADC converter. So now we are going to generate the ADC driver. So select the ADC converter. Here is a unused, make it as a used. Here is a comparator operating setting. It is a strong, use that comparator operating. You want to compare the some operation setting. So operation, so resolution, whatever you want to select, 10-bit or 8-bit. so make sure you know the calculations of the ADC count, how that will calculate it, 2:10. So your higher count will go more than 1024 near about. and if you are going to use the 8-bit resolution, your count will go 256. Okay, so here we are selecting the 10-bit resolution, and for the reference purpose we are giving the voltages whatever you are given to the MCU, whether you are giving to 3.3 volt or 5 volt. Okay, so my MCU is now operating the 5 volt, so here is reference is my is for 5 volt. So here the VREF also you can use the select this VREF as well, but this VREF if you are using the VREF, that time this pin will showing the conflict detected because of this analog 0 was used as a VREF positive and VREF M. Okay, so make sure which reference you are going to use, external reference or internal reference. So I am using the internal one. So next is a triggering mode setting. So here are some triggering modes. There is software triggering mode, hardware triggering mode, or hardware triggering wait mode. There is a no wait mode and wait mode. So this is a triggering when the input is detected, that time it will trigger that mode, whether it is a software triggering or a hardware triggering. External hardware is a external triggering. Then next, this is a operation mode setting. There are some operation is there in continuous select mode, one shot select mode, continuous scan mode, or one shot scan mode. So there, so we are going firstly we will use continuous scan mode in this tutorial. So next part I will show you the continuous scan mode. So I don't want to use these pins now. I am using only the one channel. So select the analog 0, and here it is showing the internal reference voltage as output, but whenever you are going to use, make it select this one as analog 0. So it will select the scanning the channel from the 0 only. Okay, make sure it will also select as analog 0. Then conversion, this is a conversion time. This normal, now I have selected that there are some other also normal 2, low voltage 1 and low voltage 2. Okay, so normal. For the detailing to study this one, you refer the hardware manual. We'll see the hardware manual as well. In conversion result upper and bound values, we will say the standard 0 to 255, and this one is a interrupt setting. We will take that one. For the detailed study of this trigger mode and operation mode setting, refer the hardware manual. This MCU RL78 G13 series is there. So you can download the hardware manual from the Renesas website. Then open this chapter 11 ADC converter. So here all the functions already they have mentioned. So 128 pin. For how are using the 64 pin, so 64 pin it supports the 12 channel analog 0 to analog 7 and analog 16 to analog 19. So it's having the 10-bit or 8-bit resolution conversion mode. Here is some detailed explanation they have given in the triggering mode, having the software triggering, hardware triggering no wait, hardware triggering wait mode. In the software triggering, conversion is started by the software. Hardware triggering no wait, conversion is started by detecting a hardware trigger. Okay, and here is a hardware trigger wait mode. So when you using the snooze mode function, safety the hardware triggering is going to the wait mode. Okay, so snooze mode, this some modes is there: hard mode, snooze mode, and stop mode. This for the power saving modes. Then channel select mode, there are a select mode and scan mode. In select mode, ADC conversion is performed on the analog input, one selected channel. Only the whatever the conversion is performing, only one selected channel. So if you have selected the analog for channels at 0 to 1 to 3, so it will conversion happens only on the one channel. So when you have selected the scan mode, that time ADC conversion is performed on the analog input of four channel in order. There is a consecutive channel it is scanning from 0 to 14. Okay, so this will I will explain you in the next tutorial. Maybe this video will go more. That's why we'll make it is that make the second part. And this is a one shot conversion mode and sequential mode, then operation voltage, then standard one and standard mode 2. So already we have selected the 2.7 volt to 5.5. This is standard one and standard 2. So if you have seen here, there is some normal one, low voltage and low. This is some standard, some they assume. Sorry. Okay, we come again in position. In hardware menu, there is a sampling time setting is here. Selection. If you go down, there all the in chapter they have all explaining all the conversion and ADC channels. Okay, input voltage conversion and result. There is a SAR ADC. This is a formula which converting the values or count of the analog signals. Okay, and it's consecutively scanning one by one. So this is a ADC conversion operation mode. So this is a flow actually. So I recommend you can refer this for your deep knowledge. There is a software triggering mode, then select mode and sequential conversion mode. Sequential conversion. Okay. First, these are steps to execute of the ADC in the driver side. Okay, and this is a graph. Okay, I hope you will refer this. So now we'll go in the software. So after doing this, generate a code. After generating a code, you can see here code generator folder will created. In code generator folder, the main file, then some .c file and .h file is there. So we'll open this adc.h file. In adc.h file, all the hash defined function, all hash define is there. And here are some functions which we are going to now use. We create function, start function, stop function, set operation on, set operation off, and this is the get result. Whatever the count is getting, we are getting from here in this buffer. Okay. Open the adc.c. In adc.c file, there is a API function r underscore ADC underscore create. So this is the initial necessary to control the ADC converter. Okay. And second is the ADC start is there. Then ADC stop. These are drivers. Okay. Then operations, set operation on and operation off and result. Okay. So in user, we know in user our interrupt API is interrupt function is available. So to start the ADC, first you need to call this r underscore set operation. So this remark already they have given about the 1 microsecond stabilization time is required when the changing the voltage conversion of the operation. So minimum 1 microsecond is required to time to convert the ADC. Okay. Then remark 2 is showing if the operation is selected, then the voltage converter will be switching to the always on. Okay, and it's having written none, so it's not returning anything. So first copy this, then go in main function, operation on, call this VPA, then start the ADC, copy this, start. Okay, now we have called this set operation on and start. Make sure this set operation you need to call before of the start, ADC start. If you call this set operation after the start function, then maybe your ADC count you will not get. So for the result getting, we need to call this ADC get result. We will call this ADC get result in the ADC interrupt. So whatever, every time when we will get any trigger or any interrupt, that time we will get the value. Okay, count, ADC count, we will call this variable. We will take one variable ADC count, and this is a count, maybe goes to integer. Okay, take the int value, then build this. After doing this one, build the your project. Okay, so here we have used the analog 0. So make sure you know where you need to connected this analog 0. So you will see reflect in pin. In top view, there is a port 20 is carrying the analog 0. It's also having this VRF external we are not using, so that's why we have given the reference externally. This we are using the VDD and VSS for the reference. So P20. So in this only we will see the count value of our voltages in the simulator. So for this go in simulator, select the simulator, this one. Okay, it's already selected, it's simulator. Then download it after building the project. Then your simulator GUI will open. So in simulator GUI window, you need to configure the analog channel to give the input to that analog 0 pin. So here we will select the analog 0 panel, it as a hand. Okay, double click on it, then pin number port 20, you know, which is a analog 0. So select this, where a maximum input voltage we are giving 5 volt. Okay, so this is 5000 millivolt. Okay, so to see that our count is increasing or not, we'll take that our buffer in the watch window. Let's just right click on it, select on that watch window, and here ADC count is now it's showing 0. So start that. So suppose I am now here increasing my voltage to 0.03, so to 203 millivolt. So my count is coming 24. I am increasing my voltages, then count is going to increase. So I am making it is a full 5 millivolt as a 5 volt. So my count is going to 1023. So it's so my input or my count is coming correctly. I hope it will clear from you here. So for other I will show you in my next tutorial. Continuous scan mode. We will see this continuous scan mode in the next tutorial. Thank you. Thank you for watching this video.